Well, some people have done this, and you should. This is from Monday. This is now Thursday. This is why this was due Tuesday, and you had work time on Tuesday also. Yeah, it is. Okay, we need to remember that the limit as x goes to 0 of the sine of x over x is equal to 1. What if I have this? The limit as x goes to 0 of the sine of x of 2x over 2x. And actually, I should say 2x goes to 0 is equal to 1. That's the trick that's involved. Whatever this is, these have to be the same. So if this is 2x, that has to be 2x, and then that limit is 1. Okay? Remember doing those? We did these last year. And I could do a substitution. I could say, if you want me to show you why it is what it is, I could say let h equal 2x. Then it's the limit. Well, if 2x goes to 0, h goes to 0. And that's the sine of h over h. We know that's 1. So I could do a little substitution to change it to look like that. So I have to do some work here. First off, I'm going to split this up as a product of two fractions. I'm not going to take that limit because right now I've got 0 over 0. And it's the tangent of 6t over 1 times 1 over the sine of 2t. So, if I want to do that, actually I almost made it harder than it was. Okay, what do I have to, well, no, I guess not. What do I need in the numerator here to get the sine of 2t to go away? I need more than that. I need a 2t. Right? Because that's the same as this. It's the reciprocal of this. So let's put that in our list. The limit as h goes to 0 of the reciprocal of this, if you want me to show you why that is equal to 1. Because that really is this limit. As h goes to 0, and it's 1 over the sine of h over h. So it's 1 over 1. And we just kind of gave it to you last year because it's a little harder for you guys know the algebra a little bit better. And you got to look back at the algebra you do know and what you've learned in between last year even and this year. And from pre-calculus, it's a lot. You should be proud of yourselves for everything you've done. Okay, so I know that this limit, I can go ahead. Oh, I have made a mistake though. I'm not quite done with this. I put the 2t here, but it's not fair. I got to put 2t here. Now it's fair. Now I can break this up using the main limit theorem into two limits. Now, I don't always write it out, but I will for you. So it's the limit as t goes to 0 of the tangent of 6t, over 2t times the limit as h goes to 0 of 2t over the sine of 2t. It's just a math trick. What's this limit equal to? 1. And then you can come up and you can try the other problems after this, but they're all done in a similar way. And then I need to work on this one. Well, what can I do with the 2 right away? Remember this? You should write it down. It's a homework problem. Because, you know, I might let you use your homework on your next homework. I might not. But I can pull this 2 out. So it's what in front? 1/2. Then, now here's what I call another trick. And it's okay because of the main limit theorem. This is, what is tangent? Yeah, it's the sine of 6t. Yes? I do. Cosine of 6t over t. Now, the main limit theorem says that you can go ahead and distribute this limit within that fraction provided it exists. And it does. And so what I'm going to do, just to make my life easier, because the only issue is at 0 over 0. There's no issue when you evaluate something and it's not 0. Right? Does that make sense? The only issues with these limits are 0 divided by 0. Every place else, it's just a number. That one, is that 0 when t goes to 0? Is this 0? Cosine of 6 times 0? No, it's 1. So you can go ahead and evaluate that because it's not 0. The holes occur at 0 over 0, not at the 1. The 1 is not an issue. So let's just evaluate that and get it out of the whole problem. Because that's 1. So I'm left with 1/2. And now you should see what's going to happen as t goes to 0. If you want me to write it out using the main limit theorem, I can certainly do that. So sine of 6t over t. Because that's just 1. And otherwise, I could manipulate the fractions, but you know, we're not really that great with fractions. So why would I want to do that? Okay, I want this to match. It doesn't match. What do I need here? 6. And if I put a 6 here, I need to put a 6 in the numerator. So we'll pull it over here. Okay, Dylan, this is stuff that you did in AB as well. So this is 1, and this is 3. And I don't want to see you get this wrong on the test. I'm very, very clear and direct. It's on the test. How to do a problem like this. It won't be the same problem. Then that's memorization. That's not understanding. So if we go to the next one, ooh, 45 looks kind of hard. Does it? You can try 44 and 45, and they're all different. I can give you more if you want. There's more questions on 3-3. Do you have a quick question on 3-4? Which one? Oh. It's just the chain rule. What's V of D? What's V of T? It's the SDT. Are you looking at 75 or 76? 75. V of T is the SDT. Yeah, you're just going to use differentials. That's hard. Same thing. It's talking about with respect to. Here's the chain rule. You want me to jump there? Okay, let's go to, we'll jump to 3.4. Then we'll probably come back. There's more problems like that. They are done on your solutions. Hey guys, you're supposed to be working on math, and I don't know if you know how to do this. Okay, how do you do 75 on Well, they asked the question. I'll do a question. I'll do as many as I can. 75. So that's on page 207. A particle moves along a straight line with displacement s of t. Nothing else, I'll write something down. Velocity v of t. What is v of t? It's the SDT, right? And, what am I looking? An acceleration, a of t, which is dv dt, right? Or the second derivative of the position. Okay, guys? And it says, show that a of t is equal to v of t, and I would work backwards, times dv ds. And actually what I would do is work backwards to figure out how to show that and then write it in the correct order. This would be the correct way to do it. And what's the difference between the meanings of the derivatives dv dt and dv ds? That's what's important. Maybe we should answer that question first, because maybe that's what some of the problem is. I'm not sure. What is dv dt? Remember, a derivative is, but I want to understand the derivative. A derivative is how something changes as something else changes. So this is the change in the what? In velocity as what changes? As time changes. That's the same thing. What are they looking for on the exam? They're asking for the English. What does it mean? Don't give me instantaneous rate of change of the velocity, because that's not what it's asking. says, what does it mean? If time changes, how does the velocity change? What does this one mean? It's the change in the velocity, what? In velocity as the position changes. So if you change your position, how does your velocity change? So if I come up to a stoplight, that's my change in position. What happens? And it's red, my velocity is going to be 0. Okay. So when you're looking up here now, what is v of t? What's a of t? Let's look right here. A of t is what? That's dv dt, right? What's v of t? ds dt times dv ds. What happens to little differentials? Because they do represent the change in the distance, the change in the distance. They cancel. Isn't dv dt equal to dv dt? That's an informal proof, probably way more difficult. I probably would start with this and say dv dt is ds dt times dv ds, and then make that dv dt, and dv dt is a. That's how I'd write my proof going down. And I'd have to check and see what the author says. It is. It is. So when you look at 76, it's a similar thing. And sometimes they're more complicated than this. Well, let's do 76. I don't even know what 76A is. Okay. Air is being pumped into a spherical weather balloon at any time. The volume of the balloon, v of t, and its radius, r of t. Okay, so 76, I have v of t. In other words, the idea is it's not all x's and y's. And I put up on your resource page, you guys, a link about how they actually use calculus in a legal case. This is a rate of change, yeah. What is the derivative of dv dt? What do the derivatives of dv dr and dv dt represent? What's dv dt? The change in volume. But if you were to explain this to somebody, you'd say it's how the volume changes in time, right? As time changes. Guys, you need to sit somewhere else. What's dv dr? It's the change in the volume as the radius changes. So if you're blowing up a balloon, and you have the radius, you could talk about how does the volume change if the radius changes, gets bigger. Or you could talk about blowing up the balloon, how does the volume change as time progresses. And then as time continues to progress, if it's just a regular balloon and not one of those metal ones, like foil ones, then it goes back down to nothing, doesn't it? Over time. If this one makes sense, dv dr. Okay, so how do you link those two things together, which is B? Express dv dt in terms of dr dt. So if you have v of t, dv dt is equal to the change in the volume as the radius changes times the change in the radius as time changes. The chain rule. That's it. This is number 76. No. It says express dv dt in terms of dr dt. So dv dt is some number times dr dt. We could do it, but we're not. Yes, we'll be doing related rates, if that's what your question was earlier. Okay, it's just that they want you to chain it. So if the volume were this, 4/3, let's assume a spherical balloon, r cubed, then you would have the change in the volume with respect to time. Now we can do it because we did the implicit stuff. Is 4/3 pi. Then it's the derivative of the volume with respect to the radius times then the derivative of the inside function with respect to time. My guess is he's trying to do the chain rule and kind of get you into the implicit differentiation kind of thing. It's just the chain rule. So what is, that's the answer, the threes go, 4 pi r squared dr dt for that particular problem. So what if I do the derivative with respect to x of y squared? First I find the derivative of y squared with respect to y times the derivative of y with respect to x. That's the chain rule. Do you get d dx out of that algebraically? The dy's would cancel, and you end up with dy squared dx. Don't I get the same thing back? That's what it's trying to get you to do, to understand how a derivative is as something changes. It always has to be a comparison. So that's why this is 2y, because that's the derivative of y squared with respect to whatever that function is. If I wrote it this way, d of f of x squared dx, you wouldn't have any problem with that. You'd say, oh, well, first I have to do the outside function, the squaring function. So it's 2 times f of x to the first power times the derivative of the inside. Well, you know what I'm going to do? I'm going to change f of x back to y. So it's 2y times dy dx. I'm hoping that makes more sense. I did do it this way last year, but you weren't to this level, and so it should make a little more sense this year. And if I have to come back and do it again, I will. Because you can talk about the derivative of something with respect to star if you want. Whatever it is. Yeah. Okay, going back to 3.3, which is fine. Oh, and there may be some parametric questions, too. Which number? Oh, that's the same one. Okay, somebody's going to help me up. The one that... No, I didn't do it. Okay, I want to actually find the derivative with respect to x of the cosine curve using the definition. What you'll see on the exam is the definition. So that's equal to the limit as h goes to 0. It's the cosine of x plus h minus the cosine of x all over h. You would look at this limit on the exam and say, oh, that's just the derivative of the cosine. What is the derivative of the cosine? Negative. Negative sine. Okay, so let's do this. I'm going to have to do an identity here. Are we doing this at a particular place? Oh, no. Yeah. No, it's cosine minus sine, I think. It's an identity. Cosine of a plus b, I believe. If I'm remembering right. Cosine. Otherwise, I look it up. Cosine b, whoops, minus sine a, sine b. Okay, so it's the cosine of x times the cosine of h. This is going to be tricky. Minus the sine of x. I have to have another limit here. Sine of h, right? Minus the cosine of x. It's the algebra thinking that's going to be tricky here. And I suspect I'm going to need this limit. This is why you need to do homework and ask questions, because you don't know how to do this. That's okay. I don't give you the ones you know how to do. That's a waste of your time. Do you remember this one? The limit of the cosine of h minus 1 over h, as h goes to 0, is 0. We did it last year. I can prove it. All you do is multiply by the cosine of h plus 1 and work it out, and that one's easy. The sine of x over x, that one's not easy. Okay, so what I'm going to do is look at this term with this term. Okay? I'm going to reorder it. Might bother you, but I'm hoping not. And this is just algebra. It's the limit as h goes to 0. And I'm going to rewrite these as separate fractions. Well, not really. I'm going to do this. Cosine of x, cosine of h, minus the cosine of x, all over, well, I don't know if I want it over h. I'll just leave it like this. And then I'm going to do this. Minus the sine of x, sine of h. And it's all over h. Okay? And then I can regroup this into really two problems, because h goes into everything here. So what I'm going to do is group these guys and factor out what? Cosine of x. The proving the sine one's a lot easier than this one. So factor out a cosine of x, and I'm left with cosine of h minus 1 over h minus, this is not times, so it's minus, my limit's going through the whole thing, sine of x, sine of h, all over h. Kind of cool. What is this limit going to be? 0. And I can pull the cosine out of there, because guess what? This is a cosine of x, this is h. Two different variables, I don't care. Pardon? I can pull it out because it's not the same variable. So I'm left with, I get the limit as h goes to 0 of minus sine x. I'm going to do the same trick again, sine h all over h. Guess what? I can pull this one out in front like a constant because it has nothing to do with h. So it's minus sine x times the limit as h goes to 0 of the sine of h over h. That's 1. Isn't that cool? You remember what these, because that's 0, so 0 times the cosine is 0. You learned a little more about limits. Limits only apply to the h's, not the x's, even though they're both variables. I can pull it out and make it the cosine of x times this limit. Well, technically, I suppose your college profs might say, yes, you better do that. There. That's 0. You sure don't want to see the proof of that? No, because these are two separate limit problems. There. Now, I cleaned up the parentheses a little different. Isn't that cool? That's what you do in real mathematics. Things like this. Last year was like Algebra 1. This year is like pre-calc.
I wish it was Algebra 1 last year.
But I mean, the jump between BC and AB Calc is there. It's like, no. They have enough trouble. And plus, we don't have enough time. Time's more of an issue, actually. Are there more you would like me to look at? Which one? And I got him at full power. Want to go back to 3-4 and try 45?
45?
See why you need to do the homework? And I don't mind not doing inverse trig until Tuesday. If tomorrow you will actually work in class.
We always work in class. Tomorrow.
Because I think we might still have a lot of questions.
No, we always work in class.
On math.
It's like a test. Would you make us prove that?
No. No, but I do give you more, and what you do is you cheat yourself out of some of the enriched problems that I do give you in the homework. Yeah. What? 3-3? 84? There's no 84 in 3-4. Oh, 3-4. I'm on the wrong section. I was going to do 3-3, but okay. Ooh, a parametric one. Notice it has a little graph by it. It has a little picture of a graph, which means we're going to use our graphing calculator. Okay, show that the curve with parametric equations, x equals sine t, and y equals the sine of t plus sine t. Marcus, have you tried this problem yet?
I'll try.
He hasn't looked at it. Has two tangent lines at the origin and find their equations. Illustrate by graphing the curve and its tangents. Personally, I think I want to graph the curve first. Don't you? Well, I don't know what it looks like. Whoops, I'm looking at the wrong place. Show that the curve has two tangent lines at the origin. I want to see the picture. I don't know about you, but I know it goes through the origin because it's 0, right? Well, we could look at the picture. How do you find the tangent lines? You have to find dy dx, right? Which is dy dt divided by dx dt. And I know it's the origin. So what's t? 0 equals the sine of t. So t is equal to 0, pi, 2 pi. I want the first place that these times intersect. And 0 is equal to the sine of t plus the sine of t. Well, how do you know? Well, this has to be, could be 0. So t plus the sine of t has to be 0. And I can't solve that algebraically, but I can by thinking about it. Does t equal to 0 work here? 0 plus the sine of 0, that works. Does t equal to pi work? Sine of pi is 0, but unfortunately t is not 0. So it's going to be this 0. So all you have to do is find the derivatives. But it is, but it's pi plus 0. It has to be 0, remember? But you're adding t to it. Oh, I see what you're saying. Oh, and then when I put it back in here, pi is still 0. Oh, we might, that's maybe the second line. I don't know. I don't know if I've ever done the problem before, to tell you the truth. This is the first we did this solution flashing, not me. So we have, it says two lines. So it does happen twice. Yes. Usually they consider it to be just 0 to pi. By the way, I did learn something that was interesting. If you have this capital S, a sine of x, then they're talking specifically that x, is it inverse tangent? Maybe it was inverse sine. Then x is going to be between pi over 2 and negative pi over 2. You're limiting the domain if it's a capital. So if I do y equals that, I'm limiting the domain. No, I just thought it was interesting. I didn't know that. You capitalize the s and the c on the cosine t. Same thing. Never heard of that before, but that's okay. So should we find dy dt? What's dy dt? We're going to run out of time here. dy dt is the cosine of t plus sine of t times, the derivative of the inside, which is 1 plus the cosine of t. Did you guys do that? What's dx dt? That's easy. Okay, so we're going to do this at t equals 0 for sure. So dy dx, you guys, you're not going to know how to do this. Is dy dt at 0. The cosine of 0 plus 0 times 1 plus the cosine of 0 all over the cosine of 0. No, this is 1, and then this is 1 plus 1, so it's 2. Hey guys, ready? What's the equation of this line? Why are you here? You know what? I'm probably going to put this on a homework quiz. That's the problem. I'm probably going to put this on a homework quiz and let you use your homework. And then you're going to say I'm being unfair. All of this is fair game for tomorrow, even, for that matter. So, not an ounce. Y minus 0 equals 2. As long as I've covered the homework, I didn't say I would always announce it. But you know what? This is 3-4, which is due for today. Well, if I let you use your homework and it's right here on the board, what's the problem? If I'm doing it in class, maybe I'll ask those too. But if you don't have it written down, not.
I've already got this one.
Do you? Where's the other one? Is the other one at pi? It says there's two tangent lines. Is it? It's at pi? Because we're out of time anyway, because it's 12:05 and stuff. But you're going to have to do t equal to pi, and then that'll be a different answer, won't it? Now, does it repeat at 2 pi? Will you repeat answers? I'd have to actually graph this. Remember I said in the beginning I wanted to graph it because I don't know what it looks like.
Wait, I thought you couldn't use time.
You can, because when you put it back in here, sine of pi works.
Oh, that was number 84, right?
Yeah.
Do you need tomorrow as a work day, or are you ready to go on? Oh, sorry. Guys, you got to tell me.
Is there a retake the challenge individual?
I think a work day might be nice tomorrow.
What?
Well, I'm sick, so I don't think it is. But